Hello everyone. This experiment is called Calibration of Linear Variable Differential Transformer or LVDT. So this is the instrument. This instrument is used for the measurement of thickness of objects. So this instrument works using the principle of electromagnetic induction. We can see that this is a moving plunger and there is a coil inside this. When power is supplied, the current passes through the coil, and when this moving plunger goes inside, an EMF will be induced here. So from this EMF, a value will be shown here. You can see that when I switch on this, if I move this plunger, there will be difference in values. That is because EMF is induced in here. So using this principle, this instrument can measure the thickness of objects. So now calibration. Our experiment is calibration of LVDT. So what is calibration? Calibration means that we have to check the error of this instrument by using a standard value for measurement. So now here we are using slip gauges as standard objects. So the measurements given in slip gauge, we are taking it as accurate measurements. So now what we will do is that we will clean the surface of slip gauge and we will clean the surface of work table and keep the slip gauge under this plunger. So and before doing that, you can see that initially there is a value. So in order to make it as 0, we have to press this button. So after that, we are inserting the slip gauge. Now we will get a value, corresponding value of the thickness of slip gauge. So now we can compare the actual value, actual thickness of slip gauge and the measured value. So and that difference will be the error of this instrument. So now for taking multiple values, we have to move this plunger and keep it in another position. So we have to take two trial values of the same slip gauge. Like that, you have to take 20 values from 0.5, varying from 0.5 to 10.5. You have to take 20 values of slip gauges as standard values and measure the trial 1 and trial 2 in your tabular column. So after doing this, you have to calculate the error. That means the difference between average of trial 1 and trial 2 and the standard value is the error. And by finding out the error, you have to plot a graph by taking x-axis as standard values and y-axis as the error that is obtained. So the error may be negative or positive. So in order to plot that, you have to mark the graph from center axis and plot it in likewise positive and negative values of error. So that is the experiment. By plotting that graph, you will be calibrating LVDT.